At large scale, temporary work is an important element in railway construction and construction organization design, and its plannings play a key role in the overall layout. Duration, resource allocation, and environmental protection of construction. Especially in China, high-speed railway engineer construction applied a large number of new technology, new technique, and new equipment that appears to make beam yard, track plant, prefabric yard, and other ordinary railway that not have the contact. In China, railway construction remain large-scale temporary work include track lay base, beam making storage yard, track plant, prefabric yard, fill station, and material storage base, and other engineering support fertility. Now we can see the track line base, and the role of and the characteristic of large technical project. Real line base is an important element in the railway temporary engineering. It is the loading and unloading of rail line materials, storage, and process space. It is the rail section turnout assessment base. But rail line base is an important element in the railway temporary engineering. It is the loading and unloading of rail line materials, storage, and process base. It is the rail section turnout assemble base. The set of the base should be planned in according with the construction organized design clean target combined with the construction technique and method of interdiscipline. This picture is the track line base. First, now we can see the rail line base location section. The location section is very important. In according with the relevant regulation for the design of large-scale temporary working and transportation work for railway, the location of the track line base should comply with the following provision. First, the setting of the base should be combined with the length of the track line, set up field condition, the supply range, and the amount of line operation, turn, and geological and transportation condition, materials support supply, and other factors to determine the economic comparison. The base can be introduction by the existing station or the new railway contact line turn off, and then set up a temporary introduction line from the track line based into the new railway contact line or the new railway line. The second one is the base supply reduce should be based on the introduction of railway conditions along the line, rolling stock supply and other factors. Double line should not be greater than 200 km. Single line and the third one is a good traffic condition near the base, connected with nearby railway and highway. The base should be set up with the access road for car and cranes. Granted cranes track to facilitate to the loading and unload of materials and the assemble operation of machinery. And the implementation of the track line base and related line should be based on the overall construction organization duration target, the overall design, and the transition scheme design of existing stations yard should be carried out first, and then the construction of the track line base and related lines should be arranged in according with the volume of the work and the track line period requirement, which should be general construction about 9 months before the track line. Determination of the style of the track line base. The design scale of the track line base should be comprehensive mouse track line, comprehensive and track line model, transform operation model, and design of continuous track line time equal and comprehensive determination. Generally speaking, in the seamless line track line base, when ballast track use one-way line track, the base storage volume can be based on long steel rail, 75 km, reinforced concrete rail sleeper, 16,000 design turnout, and accessory should be based on the amount of baseline turnout. Materials supply situation. When use two-way line rail, base storage volume can be according to the long steel rail, 150 km, reinforced concrete rail sleeper, 130,000 design. Due to the increase of ballast field, ballast track line base cover an area larger than the ballast track line base, and the ballast track line base can be designed for integrated mouse line capability and line method Real projects method transform loaded and unloaded method. Uh, the long Theodore slope of the connecting turnout line should not be greater than 0.6 uh, percent, and it should be not greater. It not be greater than 20,000% under difficult condition, and the radius of the play cover should not less than 300 meter, and the turnout should not be less than uh, 9. And the and the distance between adjacent materials pairs should not be less than 0.7 meter, and the space of the standard and the building boundary with the base should meet the operational packing, access, and maintenance requirement of large machinery and rolling stock. And the guarantee loaded and unloaded line should be located on a flat straight line, and the long rail should be lifted and loaded with fixed granite crane. And the long rail storage area should granite crane into the rail platform should be evenly distributed. Long rail track should not be greater than 7 layers. And in order to save land, improve the smoothness of the line, meet the quality, safety, investment, and other requirement, high-speed railway more than use the bridge instead of road structure type. Prefabric grade are widely used, including 32 meter, 24 meter. Whole box grader is the most common, as the planning and the construction of the grader yard is directly related to the overall construction process and affected the project investment. It must be taken into account during the railway construction process. The overall planning step of the beam making yard can be carried out in the order of site selection. Selection of large equipment for the beam making yard. Determination of key parameter for the beam making yard. Beam making yard plan, and this step may be crossed and adjusted during the step-by-step planning in order to achieve the best overall planning for the beam making yard. And the location of the beam making site should be determined on the basis of a comprehensive consideration of technical, economic, and varied factors, and a multi-program economic and technical comprises. Generally speaking, the following factors should be taken into account. in selecting the site for the grader making storage yard. And the principle of the combined permanent and temporary site. According to the principle of the combined permanent land with temporary land, the station and other permanent railway land areas should be used as far as possible. Or the beam making yard should be located or permanent construction land in the local planning area. The second one is the low land as acquisition, demolition, and reclamation. It is advisable to locate the graveyard in an area with less arable land, less demolition and relocation, and less reclamation after completion of the project. It is advisable to set up the grader yard in a connection area of the bridge ground. The site should be located near the center of the gravity of the bridge ground to reduce the distance of the grid. At short transportation distance is very important. A short transportation distance can ensure the safety of precast. And the scale of the bridge making yard should be determined according to the number of bridges made and erected in the construction section, the direction of the track line operation, the duration of work, the production process, and the economic transportation range. Generally speaking, the construction section with centralized prefabric action and two-way erection of bridge is controlled with 313 km in pre-prop, and the construction section with one-way erection is controlled with 20 km in principle, and the number of bridges made and erected in each construction area is generally controlled at about 700 holes. The second is the track plate prefabrication yard. But these track plants generally adopt factory prefabric it is built field scale depend on the size of prefabricated engineering volume and supply period. And in workshop 2 completed the process of track plant. The track plant after inspection and pre-manufacture before open storage. Track plant is generally divided into 1 and 2 type. For different track plant type is each prefabricated field layout is different, which one type track plant prefabricated field mainly by the production area, water area, and storage area, protecting area equal. Two type track plate prefabricated field mainly by the roof plate prefabricated area, grading assemble area, storage plant area, protecting area. And the production action of the prefabrication should be determined according to the equipment, pre-storage time, and demand, and combined with the production process uh, and more production efficient calculation. When the field finished the products of precast yarn are transported by railway, a turnout line should be set up to connect with the existing line. This is the track plant prefabrication yard. And according to the different type of road-based filler, filler mix station can be divided into improved solid mix station and graded gravel mix station. The location and size of the mixed stage of improved solid and graded gravel should be determined by technical and economic comparison according to the construction, transportation, and engineering condition, supply strength, and other requirements. Generally speaking, the mix station should be set up in a flat terminal with good construction water supply and as close as possible to the construction site and area material supply and away from the village. The traffic is placed. The mixed station is often located outside of the construction road with a lease area of 15 to 13 acre, and the improved solid mixing station is primarily placed in or near the solid collection site, taking into account that the graded gravel is mostly used after the improved solid is filled in the roadbed. So the graded gravel mixing station should be used as much as possible. At the existing facilities of the improved solid mix station can be set up independently if necessary. And the design capacity of the field mixed plant, which consists mainly of the material storage area and the mixed area. It should be determined according to the maximum amount construction task and the peak intensity of field. The mixed station site shall be determined according to the maximum amount construction task stake. And the location and size of the concrete mix plant should take into account the time requirement for the use of mix, and in addition to meet the relevant requirement in the field mix plant. As concrete has transport time requirement, its supply reduced should not be greater than 50 km. And the concrete mix plant should focus on the construction of the major structures such as tunnel and bridge, while take into account smaller structure in the victory and take into account construction conditions such as road, site, and power supply. ballast storage space. Passage rail ballasts have high quality standard storage of resource, long transport distance, uneven distribution, and high intensity. So it is advisable to organize to the prayers of materials 1 year in advance to meet the need of the construction and the construction of transportation access road should meet the requirement of construction transport with emphasis on its safety, economy, and transportation convenience. Temporary water supply. Water for construction, demonstrate water for fire, flight, and water for construction vehicle will, in principle, be solved by the construction units themselves. In the case of In the case of inconvenience use of public drink water facilitated for use can be made of surface water and groundwater along the railway line of the passage and dedicated line. In process of mining and use groundwater, attention should be paid to the protection of groundwater to avoid water quality pollution and affect the whole groundwater system. And in China, high-speed railway construction, the precast concrete grade plant is a very important large temporary facility which completed the whole process of concrete grade production through formwork process, steel process, and installation, concrete production and transportation, casting, maintenance, intelligent testing and process, beam storage, and beam removal. At present, beam Internet of Things, intelligent prefabrication, and other technical means are used in the intelligent production process of concrete beam, breaking the production panel of traditional precast grade yard. This is the intelligent process of the beam plant process. Let's introduce the application of beam technology in precast grade yard. The beam collaborative. The beam collaborative management platform adopt automatic monitor, sets, intelligent control system, and other technical means to visualize the outside construction management process through beam and at the same time incorporated three major systems of arithmetics into the management platform in conjunction with intelligent manufacturing of box grader. The platform can work together from the client, web, and mobile phone, and to meet the need of different application scenario. And the BIM information management platform is used to achieve three major functions of grader yard management, which are as follows. First one is site dynamic management and materials management, equipment management, quality and safety management, field management, digitalization of pre-production. Second one is BIM software is now we use the BIM. BIM means build information engineering management, and we now use the BIM software very widely. Maybe you can also you can use other software to achieve this target. And in China, many management want to achieve the intelligent target, and the BIM is also the BIM software is used in the such as railway engineering, highway engineering, and other construction engineering. And the other one is the automated process system for steel bar. Steel is also very important, and it need very the intelligent or smart technology. And in order to automate the process of reinforced steel, the automatic process system for reinforced steel is based on BIM's 3D model, generation of XML data field, model data transmission, and identification, automatic batch production by process equipment. The system is simple and fast. After importing the standard data format, the technical review and generated a sample order, which is arithmetically optimized for cutting and converted into a production task for electrical compared to conventional process equipment. The smart process equipment increase productive, reduce the number of operations working with reinforcement steel, and allowed for more acute process dimension. This is the steel machine, steel intelligent machine. Also, the concrete intelligent control system is also very important, and it can help to achieve the intelligent target. The BIM calibrative management platform enable automatic collection and analysis of process testing, grant maintainers, and concrete produce data through video monitor, wireless transmission, and other technology to realize the management objective of information and remote control of the construction process. Then achieve the aromatic control of the whole process of concrete lift, level, and finish the precast concrete beam. This enables aromatic control of the entire process of concrete lifting, vibrity, level, and finish. And the beam calibrative management platform integrated video monitor and structure strength and string monitor through the development of a data interface use video camera and intelligent sense device deployed in the beam yard area so as to control the site situation and identify risk at any time and from anywhere. With zero distance intensive control and visual intelligent decision making at the same time, the monitor system allows real-time monitor of the production area in the graveyard, and the platform corresponding the image taken by the actual monitor with the virtual camera being modeled one by one, so that the virtual model is romantic with the actually construction situation in real time. This is the monitor system. Advantage of intelligent testing system. Each advantage are mainly in the following area. Accurate and aromatic system. The whole construction process is standardized and efficient. The simulation operation of multiple jack server labor resource reduce cost and improve with efficiency. And the mirror testing process error is normally around 50% of the standard value, while the intelligent test system control the deviation value to around 100%, improve the quality of pre-stretch work. Aromatic control of the entire pre-stretch process, accurate monitor of reinforcement in pressure grouting. The intelligent process grouting equipment can achieve continuous circulation of pressure grout, which ensure the completed discharge of area in the pressure grout pill, effective eroding the cavity caused by reduced area. And the built-in process center of the intelligent grouting equipment enables real-time monitor of the slurry process of precise control of the pressure through data feedback and analysis, while dynamically adjusting and process according the actual construction need, achieve a strict control of the process and pressure stabilization time. The intelligent control system in the intelligent compaction equipment can monitor the water, cement, reticle, in slurry in time. Once the monitor problem occurs, the intelligent compaction control system will issue an alarm at the first time. Then, facilitated the technical personnel to make timely and effective adjustment, which can reduce the compaction quality defected caused by the unreachable water sediment reserve. And the third part is the intelligent construction technology for railway roadbed project. A roadbed is a geographic structure made up of loose earth materials filled in or built on top of road rubber. Due to each completed explore to the element, the roadbed project will be affected by geography, climatic, geological condition, which will inevitably lead to various degree of damage during the operation of the roadbed project. The roadbed is the foundation of the track and must meet the long-term safety operation of the track line and line state. And with the line level change in the technical requirement of the railway, roadbed also significant different. And in order to ensure the safe use of technical standard of the track and to meet the comfortable operation condition of the railway line, the roadbed project must meet the three base requirements of primary capture, stiffness, and stability. And the roadbed should be strong enough to resist the dynamic stress of the train load without damage, and refer to the ability of the roadbed to resist lamination after the road has been applied to the roadbed surface. Meanwhile, the railway project have a long service life, so the roadbed project requires good stability and durability. And the difference between high-speed highway roadbed engineering and ordinary railway roadbed engineering construction is mainly manifested in high-speed railway roadbed adapt graded gravel to stretch the surface structure. The surface layer of the foundation bed is generally graded gravel sand and gravel. The bottom layer of the foundation bed and the follow part of the embankment use group A and B fill and improved store. High-speed railway roadbed engineering construction process standard requirement generally use physical and mechanical. What is average life of a the roadbed of the railway and about the 50 years. 50. and the test index, test method, and instrument are very important from those of ordinary railway, and the surface layer of the bed is controlled by dynamic modules. The support masonry used is very different from that of ordinary railway, as the use of the heavy compaction equipment of road bed filling and the use of plant mixed method of uh generally the road bed will should need the repair and maintenance to to uh to combine the each performance. What is the common method used in China for ground improvement for common railway? Oh, um, what is common method used in China for uh? Let me think. Is use wait a moment. Sleep casting. Uh, Generally we can use the sleep casting uh to 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 before the full-scale development of railway roadbed earthwork. Fourth type of failure engineering characteristic test and failure process test should be carried out to determine the corresponding compaction scheme of the roadbed. According to the actual site in the roadbed, rate to choose 1 to 2 section of the width of the width to the roadbed and width of the overfill. The length of the not less than 100 meter of the test site. According to the different type of failure selection of different compaction machinery were carried out below the sub-base in-break method sub-base layer filling compaction process test to find out the model thickness, the number of grade and design specification between the regular cavity in order to determine each process parameter and construction method. According to the result of the test section of roadbed failure, the construction of embankment below the roadbed, the construction of sub-base layer, and the construction of surface layer of the roadbed are carried out. And high-speed railway roadbed construction is now generally in accordance with 3-stage, 4-section, and 8-process construction process. The excavation of the road grabber should be arrived according to the geography, meteorology, and other conditions to determine of a resemble way of the excavation. The excavation of solid road rift, the Rift Valley is mainly based on the mechanical construction. The rock road grab is excavated in the following three ways: for face, weathered rock, and soft rock with crack. Small, square stone sections are excavated with mescus outlet and small ground. Large stone section and layer use light, split, and deep hole loose contour blend technique. And slurry and the main work of slurry scope protection include measure and place, cleaning and trimming, slope foundation inspection, measurement, plant, and so on. And the main work contact of the pale slab tape retail wall include measurement and sample placement, pale hole excavation support, steel scalation fabrication, pale body concrete retail slab, up pale body fabricate action, fairly behind the wall, the wall. And the next part is the intelligent construction technology for road-based construction. It is the road-based construction process. From this picture, we can see the road-based construction process. And the main function of the continuous compaction control system for road-based include the four aspects: monitor and control of the fabrication and the travel state of the roller, and the compaction state of the solid is achieved mainly through real-time monitor of the work state of the roller, online detector of the compaction degree of the solid, and intelligent control of the compaction parameters. And before the start of the vibratory compaction, the correlation between the vibratory compaction value obtained from the continuous compaction test and the combination test index needed to the extension, and the VCV K30 correlation is determined according to the technical regulations and correlation tests related to the control of the continuous compaction of real road space field. And if the target value is not reached, analyze the sub-harmonic amplitude of the vibration wheel response signal and determine whether jumping behavior occurs. If jumping occurs, reduce the vibration amplitude by 1 step for vibration compaction. If jumping does not occur, if the VCV value of the detection unit meet the compaction requirement, it is greater than the target VCV value. The next compaction will be carried out at high speed with stated pressures. When it reaches the area, implement intelligent control system, human computer interaction interface, and compaction feedback control process. And in the compaction process, the compaction status of each point is determined in real time to see if it meets the compaction control target value. The compaction status of the location of the compacted section is recorded in conjunction with the Beidou provision system, and the current compaction status of the solid is displayed on the compaction degree distribution map. In the later stage of compaction, the compaction degree, uniform, and the stability of the entire compaction area are calculated to determine whether the area meets the requirement of the compaction operation. From the traditional point sample inspection to comprehensive inspect carry the entire field layer, the current state of compaction can be visible. Compared with the traditional conventional method, the random control afterward of the conventional test can be transformed into the control of the critical area of continuous compaction test. Reduce the number of tests in the conventional test method. Degree of information technology and intelligence of test equipment is high, and the operation of a mechanical driver is simple. Intelligent road-based concrete play a very positive and effective role in the reduced environmental population, reduce the labor intensity of workers, and improve the working condition of participants. Although the investment is large, but because of the personally mercenary need less construction efficiency is high. Construction comprehensive cost is much lower than the traditional roadbed field operation construction with high economic benefit. And the fourth part is intelligent construct technique for railway tunnel. Tunnel is generally strip, and the whole project is located underground, which a close relationship to geography. Therefore, the context and the property of tunnel construction are very different from those of other construction professionals. In process tunnel engineering construction according to their logical, according to